And hello, everyone. Welcome to our Camp 1012. And here is the first class. Let's applaud for ourselves. Welcome. Okay. In this semester, I'm going to stay with you for programming fundamentals and application. And more specifically, we're going to teach Python here. And I'm your lecturer, Xiaoyong Wei. I'm going to introduce myself later. Most importantly, because we're required to record this lecture every week. So we initiated, you probably already seen from my email that we initiated a Teams group there, so where we can deliver the online videos of this lecture. So it's if you like, you can join this team. Sometime if you're with a laptop, you can have a better view than this. I guess the projector is not working properly. So I think Teams will be a better place to have a better view about the lecture notes. And at the same time, I know that some students prefer the text chatting over talking. So you can ask a question there, and our TA will answer your question there. So, so you don't have to speak in that case. And also at the same time, we're gonna release some of the programs, the source code, to that group. So you can try to earn during the lecture. So I think there are some advantages there. So I encourage you to join that team group there, even it's optional. Okay, that's the teams and myself. Your lecture, I'm a visiting professor right now with the Department of Computing at PlaY Tech University, Hong Kong. So I was a visiting professor in Tampere University, Finland, and I am a professor with the department head with the Strand University at the same time. And I have been a postdoctoral fellow in UC Berkeley, United States. And I graduated from City University of Hong Kong. I was the member of a lot of research groups. I am a senior member of HB, and this is pretty much about myself. I can go on and on for a day, but I think maybe you're just not interested. Okay, the office hours is every Wednesday after the lectures, because our lecture runs for something like 3 hours until 15:30. So after that, I'll stay in my office. So we could have the office hour there. If you would like to meet other time slots, please send me an email, and that's my email address there. And also, optionally, you can call by phone to reach me there to make appointment, or just let's talk over phone directly there. So this is the time and the ways for communication. And languages here in this course, English by default. I consider myself a professional speaker of English. So that's a language by default and also required by the university. And Mandarin, I'm a native speaker of Mandarin. So feel free to ask a question in Mandarin if you feel more comfortable about that. And we can also talk offline in Mandarin there. But in the class, I'm supposed to speak in English. And very similarly, I speak Cantonese. So feel free to ask questions in Cantonese, and also we can talk offline in Cantonese as well. So those are languages we can use. We also got some TAs this week, either Mandarin and Cantonese to make it easier. So feel free to reach us. And we have 5 teaching assistants here. And Liu Ming, he's here today, and please stand up. And also we have Zicong. He's there. Okay, Zicong is our TA. Both of them actually has been my TA for a couple of years. They are quite experienced and feel free. Should you have any question, just reach them. And also Zhang Shulu is here as well, and he's one of our PhD students. And Li Ruibing here. So. And also we have Tang Meng. Probably he's online because he has been involved in a project in Shenzhen. So he's there right now. And most of the time, I think that he probably in the coming months, he's going to join us online. And however, feel free to ask questions through this email, reach them in person, and also during the break, it's a good time for communication. We can talk offline there. So those are our teaching assistants. Thank them very much. Okay, let's stop the chit chat and get back to the course. And in this semester, we're going to work with the Python. Python is a language, but we play it a little bit, but make slogan about this course. Play with it on. So that's what our understanding about the Python. And play means it's a programming skill rather than rock science, right? Programming is about practice. So you just have to practice, and practice, and on and on. So that's the reason we're making that slogan, play with it on. So by playing, we are trying our best to make it fun, to make it enjoyable there. And you will see it very soon. So it's a little bit joking on the Python. And it's seriously what it is, Python. And anyone here has experience on it? Please raise your hands. Actually, I see from this our survey at some of the students already have some experience on programming. So anyone? Yeah, so what is programming? I also, from as I mentioned, from the survey, some students are already got programming experience. Would you want to share for those students? Would you want to share what is programming? Is there anyone brave enough to answer this question here, to share your view about the programming? Okay, please. Ah, that's perfect. That's perfect. Thank you. Thank you very much for sharing that. There are different opinions about that. What do you think? What is programming? Instead of, as you mentioned, translating humans' understanding of languages into machines' languages there. Okay. Thank you very much. And that's, I think he's perfect, providing a perfect understanding about the programming, but it sounds a little bit official there. Right? So let's, what I'm gonna do is before we teach that in an official way. This is what we are going to do in this semester as well. We're going to play with it as the slogan showing, play with it. So we're going to play with it to show what is programming. We're starting with a music box. So I prepare a music box here, and it should already, let me switch to the visualizer view so you can see the music box. Well, I got to minimize that one so you can shoot see the visualizer. Not so good. So let me. Can we adjust that focus? Yeah, yes, right. And seriously, I'm not exactly know what's the best way of using the visualizer. It works properly before we start the course. It will automatically focus though. Focus. Just this looks better, right? Okay, let's just use that. Here's a music box. I got you already played with it a lot of times. So let's do it again here today. So the music box is like something like this. And when I turn it on, it's just playing. Right? Let's enjoy that for seconds. Okay, takes a while. I hope you enjoyed that music. And this is a music box. And does it help recall your childhood memory? It's quite enjoyable. That when I was a kid, I played music boxes a lot. But have you ever thought about one question? This music box are made like one box for one song, right? So you got one box for one specific song there. That's what it means. Have you ever thought about could we have just one box that can play different music, different songs there? And that's one box for multiple songs. Or is it possible to have one box playing the songs made by yourself? Or we could see, we can play whatever songs we like with that music box. So is it possible for this one? Is it possible? Maybe not, right? Maybe not, maybe not. But I'm going to show you something. It's actually possible. Let's play with it. And let me switch to that visualizer again. So what I have today is one such box here. So that's what I have. One box here. And let's put it aside first. I got one box and I got some cars there as well. So, and also I got a pen and got a puncher as well. Here's a puncher, which I can use to punch the car. So what I'm gonna do here is punch the car and fit into this box. And so this box will play the music according to the car I punched. So let's do it. And let's let me just mark down where I should punch first. figure out. And actually takes some effort for me to figure that out, which is the right place to punch. Okay, I roughly mark it down about the place I'm gonna punch. So what I'm gonna do here is, you see, I got this puncher, and let me just put it down, put the microphone down. So what I'm gonna do here is, like, for the places I marked, I'm gonna find and punch a hole here, like this. See, this is the first hole I punched, and I can keep punching for the second hole, third hole, and I can keep punching. Just let you see that's what the efforts I need to make to punch the car, and what's the procedure we need to punch a car. Okay. I got to do this right. Later you will understand if I make it wrong. Maybe it's not gonna play the right music. Okay, you see, this is the way I'm punching the car, and actually have a really punch one exactly the same as this one. So to save the time, I'm just gonna use this one to play the music. Let me just put it into that box. I'm putting into that box, and let's see what happens. Actually have the microphone here so you can hear the sound. Wow, that's the sound we made. So you will see here, actually, I punched a sound on a car, and this is a sound more or less made by myself, and this I picked some of sound you're familiar with. Actually, you can play with different songs, as mentioned. This is one box for different song. So let's play this. Okay, that's a song you're familiar with, right? Is it good? Okay, not that boring than programming, right? Okay, you see the box, you see the cars, And you actually witness the way I'm punching the card and fit into that music box to play music. As mentioned, here is one music box which you can play different types of songs there. So let's get back to our slides. And this is what we have and what we have done. Actually, what if I say this is programming? This is exactly the programming. So as I mentioned, we're going to play with it. We're going to provide a more intuitive understanding about the programming here, and this is one of them. Okay, so let me explain why I'm saying that this is programming. There are different reasons there, and the most intuitive one, you know what it is? This is the first generation of programmer used for programming. So this is what they use for programming, exactly. You look at that image and compare back to this one. It's almost the same, right? So this is actually punching card programming. So they are doing exactly the same thing. They punch the card because from here for the music box, actually each of those lines are corresponding different keys there. You probably already seen there at the head of that car. Actually, there is a correspondence between those lines and the keys, right? If you have ever played guitar, this is pretty much like that thing, except with different keys. Okay, for the real programming at the very beginning, they're using this car. As you see here, those different lines representing different also keys there in the machine, but the machine are connecting that key to different operations there. So as long as you can punch the car, feed this car to that old-fashioned machines, that machine will do the thing you program, you're expecting. Let me go further. So see this is what they are doing. Programming, they're not exactly typing the things, they're doing the programming. And also after those cards are punched, fit into that machine, and this is the machine I mentioned, and machine will do what you programmed. Maybe this, you will see the similarity between them, right? Feed the car into the box, feed the car into the machine. Exactly, the procedure is exactly the same, except the machines are different, but the way are very similar to each other. So for the music box, we actually, if you open up the music box, you will see there are some needles there. Those needles will respond to the holes. If there's a hole, the needle, the needle will respond to that hole, right? So this is a way to make the music box work, because each of the needle are connected to a key to the music box. So that's the way we make the music box played. So for programming, it works like exactly the same. Let's provide a more intuitive example for you. Let's see, we have a punched car, and each of those holes are corresponding to one key on the calculator, like what you're seeing here. The first one is connected to the 7, and the second one is connected to the 8, what you see here. Third one connected to the 9, so on and so forth. Anyway, they're corresponding to different keys on your calculator. So we can do something like, once we're punching this position and fit into that machine, and the calculator 9, the key line will be pressed. Okay? So to do a calculation, and you can keep this on and on, and for example, you have this position punched, you're supposed to have that multiplication key pressed, right? And Also, you go down and down this 7. In this case, what you're gonna have on the calculator is 9 multiplied by 7, right? And then you press the key of equals, and you have the answer. It's like we are pressing the keys on the calculator by ourselves. But this way, can be done automatically because it's pre-punched before, pre-programmed there before we actually run the calculator. So this is the calculation. Let's do one exercise here. What if we have a punch card like that? See here. Please do it by yourself. Try get an answer. What the answer of those punch card? This is a program. And what's gonna happen at the end on a calculator? Can you do it by yourself? So when you're done, raise your hands, let me know the answer. Can anyone do that? Anybody has an answer for this? See, we actually got a punch card with 4 lines of code, which was sent to the reader here one by one. Once it's reached here, corresponding key will press on the calculator. Then after, because we have 4 lines there. So after 4 key have been pressed on the calculator, you're supposed to have an answer there on the calculator, right? But what's the answer is? What's the result is? Anyone get that? Okay, thank you. A student is showing me this. Okay, that's right, exactly. I guess she's shy to speak out. But the answer is right. Thank you very much. And let's see what happened actually to get answer 2. And here is the first hole. It's corresponding to the 1. So the 1 will be pressed after reader reach this line of the punch card. And then for the second line, because we're feeding the cards into the reader like we're feeding them to the music box, and the plus will be pressed, right? That's second one. The third key is the same as the first one. It's the 1. So what we have exactly here is 1 plus 1. Then the last one is equals key. So after that be punched, we're supposed to have 2, right? That's a correct answer. Okay, thank you very much. And actually you have already done the programming. You are a programmer right now. It's a decent job. And especially at the very beginning, you see, people are dressed up for programming because it's a decent job there, right? They're seeing quite cool offices there. A little bit different today, right? Programmer in office. Okay. Think about that. We have done a programming with punch card together, and what is the programming language we just used there? What is the programming language? But so far, we're talking about the programming languages, actually. The Python is one of the programming languages, actually. So besides Python, you might have already heard about there are programming languages like the C, like Java, and like a lot, like R, like a lot of other programming languages there. Anyway, Python is one of them. But what kind of programming languages we're using here for this calculator example? Do you know it? It's the machine's language 0 and 1. It's very essential languages for the machine because as he mentioned, what programming is actually translating the human's languages into the machine's language. This is the ultimate goal. You are translating that. The automatically, it will be translated into the 0, 1 machine languages there. So you could see why it's 0, 1, 1, 0 there, because we can representing each of the whole as 1, and those non-punched places as 0. So when you're feeding that car to the reader, you are it's equals to the process of sending this code to the machine. The machine is some kind of not that smart. Even people would like to call them smart devices there. It's actually not that smart. The machines, the computers, they can only understand those 0 and 1. There are several reasons there, because on and off is the easiest thing for a machine to do. Like the music box, it's either press that key, play that key, or not play that key. So even right now, you have very complicated application on your laptop or on your smartphones. The essential operation is 0 and 1. It was built up from 0 and 1. So what we're using here is very essential one, 0 and 1. And this is actually the machine language used by the, what I have showed, the old-fashioned programmers, 0 and 1. So at the old time, what you have to do is just to understand the 0 and 1 and with its correspondence to that machine. You got to have a very good understanding about that. So for you to program with the punch cards. And as I mentioned right now, it's just built up because a lot of programmers made a lot of efforts. They built more and more complicated stuff. So we can reuse the programs they built previously to build up more complicated applications of programs there. But the essential one is 0 and 1. Here is how it happens. Okay, the punch card programming is fun, right? But the punching itself is boring, right? Because you have seen, I just punched 5 holes or 6 holes there. It takes a lot of efforts. What if I have to make something like this? So probably take 1 hour for that. Right? Punching is not fun. Programming is fun, but punching is not. It's boring. Right? Here, sorry. Those are cards I wasted before I figured out how to work. So I actually wasted a lot of cards there. And at the old time, you'll see this is one program, actually. You got to punch so many cards to make one program. So it's boring. Those programs, probably they just do a very simple thing, a very simple calculation, which you can do it nowadays in several seconds. But they probably have to spend 1 month to do that, which you thank them to make the efforts to make it happen. So, but anyway, what I want to say is 0-1 language is really boring, right? Is there a better way? Do you want to do the program using the punch cards? Nobody wants to do it right now. So here's the thing: machine language is they have a direct correspondence with the machine with the punch cards, but and sorry. So I'm very glad he's providing an answer that programming is something that translating the human's language, we call the natural languages, into the machine languages. This is exactly what programming is doing. So he's providing very much standard answer about programming. And we're providing those examples to help understand what happened. Some students ask a question I want to share it here about the lecture notes. We're going to share these lecture notes on the Blackboard. So we will make it available later. For the weeks after, we will share the lecture notes before the lectures. But for the first week, because we want to keep the fun there, better not have you to know what we're going to do here. So we're not showing it in advance. But for the weeks after, we're going to do that. Okay, get back to where we are. So we know that programming language is going to help us to do the programming better, right? By translating our natural languages into the machine's language 0 and 1, namely. So but how, in what way we're doing that is a concern, right? So before I'm actually officially teach how to do it, we're going to do the same. As I mentioned, we're trying to provide a much more intuitive way of learning the programming rather than just have you learn the code, learn the program. So before doing that, let's show some real example about some of the programs. And this is what usually people will do. The first program called Hello World. That is to print out a hello world on the screen. So let me show you how to do it here. So it's usually start like this, and this is demonstration on Windows, but it's really similar on the other operation systems like on the Mac and or on the Linux. So I'm gonna, we will teach that later, and you don't have to worry about that. This is just one example to get to the command line of the Windows. So I'm gonna create a hello.python file. It's actually a file, and you will see here I already prepared it. So you type in, let's just remove it and type it again. Print, it's quite intuitive, right? Because we're going to print something on a screen. So we're typing print. This is much more intuitive than the 0 and 1 and then the punch card, right? So I just save it. This is a file. You can consider it as a text file, and I guess you have done that a lot on the Windows or in the other operation system there. Anyway, after we have this hello world saved on your machine, we will have a file with the name. Let's see, hello. You will see here a file was created there. So it's a text file, and this is actually a program, and its program is programmed in languages that's very similar to our natural language, because you can guess what we're going to do, right? Create a hello world. It's quite simple. So to run it, we are using Python, and so some students are asking the question, are we going to use Python here? That's for sure. We're teaching Python here. We're using Python, not other languages there. So we're running Python. We're going to use Python to explain what we have typed here, the hello world. So after I press the enter, and you will see here the hello world was printed on the screen. And this is actually the first program. It's used Python to explain what I just have, we have put in that file. So this is the program, the first program, and let's have something more fun there. To give you a more intuitive view about the Python programming. So let's do the same. Notepad to create, let's see, just paste, copy and paste this back to that file. Let me just post the hello. So you will see this program exactly the same as what I put on the slides. So then I save it. It's a music.py. Then I can run that and the same Python music.py. See what happens. So you hear that? And actually, it's not the music. I'm just making a joke there. It's just to make some noise there. You will see here, we are printing hello world, like the first program, what we have done in the first program. And also, we're using that to print, output something, which can make some noise there. You actually heard 3 beeps there, right? So this is what we can do, use the Python program. And this is another thing besides we can play some, make some noise there. And also we can print, we can draw a picture. And let's see. I shouldn't have said we are making noise. They're demonstrating what it is noise. Right? I'm sorry for that by saying we're making noise. Okay, here's the program. Let's save it as, let's see, picked 1. Whatever you name, whatever name you like, you can put it there. So we will do the same Python. The file I just saved, pick 1. Okay, see what happened here. We print out some of the figures there and also the figure of the Python on the screen. So this is what this program is about. We are drawing a very simple picture there using Python. And with Python, we could have this program. Let me show you how to do it. Notepad, game 1. And can't find, do you want to create one? Yes, sure. So I'm just copy and paste this program into that file, and I save it, and let's run that program. Game 1. So here's a program actually can play rock, paper, scissors with us. So what we're gonna do is input what we pick. Let's pick rock. See what happened? Okay, you see here, I gave it a rock and the machine gave me a scissor. So in that case, I won the game. Let's keep picking maybe paper this time, see what happened. Okay, you see here, as a result, I gave a paper and the computer gives a scissor. So I lose that game. And let's keep doing it with a rock. And I won this time. Should I win all the time with the rock? Probably not. Let's keep inputting the rock. The rock. Is the rock a winner? No, rock is not a winner. I lose this time. So it's just the computer is just gonna change something. Later you will understand what's happening here, and we will explain what happened here. It's not. We're not sure the rock is gonna be a winner, right? So this is what this program about. So from here, you have seen that we can use the Python, the program, to do some fun stuff like making some, I'm not going to say the noise, making some sound there, and draw a picture here, play game there. And we actually can do a lot of things with that program. And you will see here, those, you can roughly guess what happened because it's, those languages we are using is very similar to the natural language we're using, right? It's more readable, right? Rather than the 0 and 1, it's boring, right? So the general steps I have used here is like I open a text file. Here on Windows, I'm using a notepad. Actually, on your Mac, you can use a text edit. And I input some text into that file and save that file with an extension .py. And usually this is reserved for Python programs, source code. So .py will let your system recognize this is a Python programs. Then you can run with the Python with using that file with that program you just programmed. Here's the general steps of programming, showing that what the programs can do and showing what we're going to do in the future, what the steps we're going to do in the future. But furthermore, this actually explains something happened on your computer. Let's see. For the examples we're using here, the steps like we are opening a file, and it's like we are preparing a new car for punching, right? You can relate this back to the punching car case for a more intuitive understanding. We are input some text there into that file. It's like we're punching holes, but in a more intuitive way, right? Because you see it's very much like the natural languages we're using. And then you save the file. It's like we have that car ready. We save that car into the box, into somewhere else, safer. And we run the program. It's like we're feeding that car into machines. And the machine is gonna run that car based on the operations related to different hosts there. So here, different operations are actually connected to the words I used in that program. So it's different action like the print. Print is one action. When your program reaches that print, he knows that I should print something on the screen. So this is a correspondence between the punching card case and what we have done with the Python. So, but what exactly, you notice here, I put a compile here, right? What is compile? Here is feed the card to the reader. Compile is actually a process of converting the program into the machine language, as I just mentioned, 0 and 1, because they already built something in between. As I mentioned earlier, programming language is trying to build a bridge between the natural language and the machine language. The compiler, or sometimes we call it interpreter, they are kind of different, but let's reserve that concept later. We will explain it later. But they do very similar thing by converting your program to the machine languages. So you see from that program, we're not exactly using the natural language. We're using languages very similar to natural language. So it's something in between. It's much easier to program, and with the compiler, it will help us to convert, as I mentioned, the words into the 0 and 1. It makes much more easier there. So this is what the compiling is doing. As I mentioned, the ultimate goal is to have the 0 and 1 machine code there. So the computer will understand what she needs to do, right? So the compiling is that process, help you to convert your code into 0 and 1 into the machine language. That's the compiling. So when we reach here, what is programming? Exactly, we have seen a lot of words about programming, right? Programming is something converting the natural language into the machine languages. It's the very first thing we got. And programming is something like the punching the card fit into the machine. We know that because those holes are connected to the keys in the machine, or something more intuitive understanding about the programming, right? But besides that, this is actually for the punching card. We know what exactly happening for programming. We know the steps about programming, and for the figure I showed previously, we understand what happened to translate the natural language like programs into machine language. We know what actually happened, but if you're standing different position towards that programs, you probably need different understanding about that, because it will help you to do the programming. So one of them is if you're standing outside the program, that means, well, I'm not clear what exactly happened here. I just want to know when I input something, okay, maybe it's not agree with what I'm saying. Annoy, right? Okay, that means when you're looking at the program from outside, I don't care what exactly the program is. What I care about is I gave some order, I gave some instruction, I need the thing I want, right? So this program doesn't give any order, doesn't input something. It's nothing. But we do have the outputs, the hello world and the 3-bit songs. So you will see here, the program is about inputs and outputs. Even here, we input nothing. And this example explains more. This program asking the user to input his name, Jack in this case, and then print hello Jack back, a greeting sentence back to the user. So here's the input, a Jack. Here's the output, hello Jack. So it's about input and output. But for most of users, they don't want to know what the programmer is doing. They just want this, right? To have the computer saying some greetings to the user. So, in that case, you need to input the name of that user, and the computer will do the grading for you. This is a program for grading. And here also, Now, some of the programs do machine translation, like here the input is a good morning, and the output is some Chinese words there. So it will help the other users understand the thing. It's a function about of this program, machine translation. So here you could see input and output if you are standing outside of that program. You know what happened. You just care about the functionality about that program. And also, this is something maybe you use so frequently. Nowadays, everybody taking selfie, and we have the beauty cameras there to make you look better. Okay? So here, it's the beauty camera is doing very similar thing by taking a picture as input, and then outputs another modified picture to the user. Here's the input and output. You can take this view to all the applications on your computer or on your smartphones, and it's all about the inputs and outputs there. So this program is from outside point of view. It's about the inputs and outputs there, or in a general sense here. Your program is a processor. It's like you take some ingredients as inputs, and your program will cook something for the user, then serve the dishes to the user there. So this is what program is doing. All the programs has a functionality there, which takes some inputs and outputs something to the user. So this is the programs, and this is why we're doing programming. So input and outputs. But if we just jump into that program, we jump into a program, well, to see what we need to do exactly, because we know that it's a processor and it should have some functionality. But how to make it happen is the responsibility of your program. So you will see here, it's all about the logic flow. Like when you're doing cooking, there are several steps you need to follow, right? You chop something, you put the oil, you put the salt or something, and you're stirring it. Those are steps. Those are logic flow about programming. So the most important thing to do programming is to figure out the right logic to do it, rather than just remember those words for programming. Those words are easy to remember, and I'm not saying it's easy to remember. It's not that difficult to handle, but the logic is the key of the program. You have to figure out how to do it by yourself before you can teach the computer how to do it. So it's about the logic. Here you could see here, like the greeting example, the logic is ask for a name from the user. Then you you make first step is display something asking a name from the user. Then this input is actually waiting the keyboard input from that user. So this is what followed when you're displaying that question to the user. May I have your name? And then the next step is have the keyboard available so user can input his or her name into the computer. Then you compose his name by adding a hello there. So you have the greeting created. Then you use print to display that to the user, so the user see the greeting there. So this is logic flow. Even it's really simple, but it's showing the essential things you have to do. So even we're teaching Python here, we're gonna show another example, but here's the first class. I'm gonna see the most important thing is about the logic, because the logic exists everywhere in this world. Okay, maybe he's not agree with that. Okay, the logic is the most important thing. That's the reason that a lot of people, including a lot of very famous guys, are encouraging everybody to do programming. It's not about the program itself, it's about the logic. Because by programming, you actually will understand the logic running in this world for different applications and different scenarios in different places on different computers and in different markets there, and so on and so forth. Okay, before that understanding, let's do something here. To do the actual program, you need to set up the Python environment on your computer. You probably already have that. On your mic, you can switch to the terminal. If you have a Linux or Mac, you can switch to the terminal model. If you can't find it, it should be in the application. You switch to the application and you search terminal, and you should have that. You click that and you have a window, which is a terminal model of your computer, where you can issue a lot of commands there. So in the Windows, you can try the Python version to check if you have Python on your computer. And also, it works in, anyway, it works in a lot of systems there. On the Mac, you can type in Python to see if you have Python there. We should have the version as well. I missed that. I should have type very similar to this version. So you will see the version of your Python. So once you have that Python available, you can do exactly the same thing like what I have done previously. So if you don't have it, you have to install that Python, but we will reserve that to our next tutorial or lab session. So our TA will teach you how to set up the environment on your computer. So you don't have to worry about that. But you will see what I'm gonna show here is there is correspondence on different operation systems, but they are actually following exactly the same steps there. So once you have that available, you can use a text editor, like in the Mac is text edit. On the Windows is Notepad, which I have shown to you. And on the Linux or Unix, you can use VI or VIM to do it. Anyway, they are just text editors. When you're doing your program, you are actually editing a text file. Yeah, even the programs do a lot of magic things, but it's essentially a text file to the computer. We could see the program is like editing a text file. So, okay, if you have the Python already and you found the terminal or the CMD, the CMD is like on the Windows, like what I have shown. You type a CMD there and you run it, you should have that command line window pop out there. So if you have this, you can do it here together with me, or you don't have it, you can just watching because this is first class. You don't have to worry about, you're not supposed to worry about that part. So but I'm just gonna show something to you. So the first thing, when you have Python and you type Python there, and you should be able to see something here. These help you to enter into the online mode of Python. That means every time you type one line of statement to Python, and then when you press the enter, the compiler, the Python compiler, will explain or translate what you have typed there into the machine language. And so you will see the results. Let me do one rather than saying it. CMD here, and then you have that window, and you run the Python. Python. Then you enter in the online mode of Python, and you input hello world like this. It's there for seconds, and in case people are doing it, are following it. Okay, after you get this ready, you press enter. You will see the hello world has been printed out on the screen. And you can keep doing it, like what I have done, playing the beep song. So you see here, it's line by line. It doesn't display something because it outputs this beep song there. So after you're done, and you can type exit to create from that online programming model. So it's get back to the CMD. And so, but what we have done previously is the offline model, because we prepare all the program into a file. So we run that program as a whole. We run those code in that file as a whole. So it will be easier, and that's the way we're using most of the time, because we can program offline and we feed, it's like we're preparing the punch cards and feed that in that machine. Okay, so the offline mode here is like what I have shown before. You can create a new file. There are different ways of doing it. You can use this equal to create a hello world file, or you can use the notepad hello py directly. But if there is no hello.py or node file you name, it will ask you, should you create a new file? Let's see it. Just do it. Let's see, we actually have a test file. Let's see, a test 1, 2, 3. Let's see, do we have this file here? File not found, which means we don't have this file. So we can use this to create a new file. So when we do it, and sorry, should we or equal and this thing adult. Let's create it. Okay, let's forget about it, and let's create directly with the text 1, 2, 3 py there. And suppose, because we don't have it, you're gonna see this one can not find the text file, test123py file. Do you want to create a new file? And once you press yes, and you have that file created, then you can type your program there. you got that ready, you can just follow the steps. First. I save that file. Then you can run that file here. I actually have done this several times when demonstrating what the program can do. But this time, you can do it by yourself. Let's run that. Run that program. What happened? It's getting stuck. Let me start a new one. Python test 1, 2, 3. So here you see the result. Hello world. This is my first Python program. So, and is anyone already got a Hello World succeed on your machine? Okay, you got it. So thank you. Anybody else? Okay, I see. Several students has already get it done on their computer, and those are actually, you will see it just simple, very simple steps there. You have to follow, and you are going to have the result. If you are on Mac or a Linux, to create a new file, you use a touch. Use a touch hello, and then create a new file named hello.py, or you can, and then you can use the vi to edit that file, exactly what we have done here. So in that file, you can also put those print hello world. Then run exactly the same way, then you're going to have the hello world. So in case, if you haven't get it down, don't worry about that. Today, I just want you to just play a little bit to get more intuitive understanding. Because as I mentioned, for the next lab session or tutorial sessions, we're going to teach you how to do it exactly on every computer, on your computer, and different types of system there. So don't worry about that. First program run, and congratulations. And if you already get it done on your computer, you can call yourself a Python programmer right now. You have it. Get it? So you see here, like, there are many steps there. Coding in Python terminal looks cool because you have seen a lot of movies that are coding that way. It looks like cool, right? So, but it's boring too. Even it's better than punching the cards, but you have to follow a lot of steps, and you have to edit the text files there as well. But there are actually something better to help you. I mean, there are something. With them, we can do it better. It's called IDE. It's like the applications are using. It's like the Word you're using for documents. You can type the program inside that Word, and upon on top of that window, you got a lot of icons there. You got a lot of buttons there, and you can press to have more functionality. And we actually have very similar thing for programming, like the PyCharm, like the VS Code. And let me show you the VS Code. So this is a VS Code. I got some programs there, but I can create a new one, just a text file at the very beginning. So this is VS Code, which can help me to type, even run the program inside that IDE. So this will more user friendly. Let me say that to as a Python program. Let's see, test. Let's just override that hello world. Yes, all right. So you will see here the advantage in the IDE there is it's easy to edit the program, right? Because you can go the lines you want, and also you can run it very easy once you have that environment configured. You can run and debug here very easy. So I don't want to make you confused at this moment. Anyway, this is something like the word office for programming, because programming is editing a text file. We have those easy to use editor as well to help you to do the program. You will see in the future even. Don't worry about at this moment. I'm just trying to let you know there is a easier way doing that. Once you have that IDE configured, so you can use the IDE to do the programming. It's not necessary to use the text notebook to do it because it's boring. It's not easy to make the lines aligned, and it's not easy to copy and paste. It's not easy to do the replacements. But IDE is able to do it. And also the IDE will help you to remember the words I mentioned. There are some keywords like print itself is a keywords for Python. It was connected to one of the operation in Python compiler. So there are different words there, but the IDE sometimes provides you some hints about those keywords, and so you don't actually have to remember those keywords exactly. That's quite important, right? It's like when you're learning English, you have to handle a lot of words to build up your vocabulary, but IDE will help you to do some of them, make it easier for you for programming. Okay. Here's IDE. What I have already showed. Actually, you can run this program in that IDE. We can demonstrate that later. What happening here is you can input your program. You can input your program here. Okay, are you down? So you can input the program here. It's just a text file. Even the IDE looks little bit complicated for you at this moment, but think about it, it's just a Word. It's just an Office software to help you to input some text. And once you input it, and you can, here are some buttons like here, because this program is running. So this button is for stopping that program. Before you run program, here's another play or run icons there, or buttons there to help you run this program. And also you can you can use its debugging function there. We will explain what debugging is, but at this moment, just remember you can ask your program to stop at specific position, because in the command line, as you have seen, once I type in the pattern to run the program, it's just run as a whole from the very beginning to the end. It never stopped, right? But sometimes we need to know the result in between. So we need the program to stop somewhere at the program, in the program, some positions inside the program. So we would know the intermediate results to check out if your program is running smoothly or correctly. So that is debugging. And we can have that program to run line by line, like in the online model. It'll help you to do that. So there are a lot of things related to debugging we will introduce later. But anyway, what I'm gonna say is IDE is a good tool for you to have that run. So you, it's another option rather than just programming in a command line. So what we have right now, we can use the notepad to modify the text file directly to do the programming. We can either use the IDE to make the job easier, but however, there is another option called online Python compilers. It's here you could see there are several links here. Let's go one of the link to show what it is. You will see here, I input that link into the browser and I reach a web page there. You will see it's an editor, it's an online editor. And here is a really prepared for you, the Hello World program. So that means you can edit your program online. And at the same time, here's a run button. When I press that button, you will see that the Hello World has already been displayed there in the output box. Here is a program, here is the output box. And see, you can do it online. The advantage here is you can skip a lot procedures we have introduced, like check out the path if the Python is installed on your machine, and like the config, the IDE, you can use directly as long as you have this link. Please help to send this link in the chat box. So in case some student would like to try it. So you can send that link to the chat box and you can go this web page to try it out. And here we can do exactly same like what we have done on our computer. Like so let's run that program. And you'll see here's the result. We can actually copy the crow program we had previously back to here to test it out. Just replace that and run the program. You will see the output. Well, it's quite similar. It's much easier, right? You got a Python programming experience immediately by using this online compiler. So pretty much about what I'm gonna introduce. Online programmer. Online programming is really convenient. So you can try it out here. There are a lot of online compilers there. It's easy to reach, and I think that's the easiest way, right? But the reason we haven't told you there is one such option is because the previous way, by editing the text file, is easier for you to understand the procedure of programming, to understand what is programming, how this text file was used by the machine. So I think it better to have that understanding, and we will do a very similar thing in the next lecture to show you that programming in that way have other advantages there, sorry, as well. But let's reserve that later. But a very important thing I'm gonna say today is, for this semester, even we will teach you how to use different compilers like those on your machine, like on different places. But for the marking, like assignment or quiz, we're gonna use the online compiler as standard, because it's better to have everybody working in the same environment and compiler, because Python itself has a lot of versions. Different versions will have different performance. Sometimes the results, the outputs of the same program by different Python compiler will be different. So it's not, we will explain why it's different and how to avoid that. But to make it consistent, to make it easier for marking and in evaluation, we will use the online one as a standard. We will come back later here. But I think, anyway, I think it's good to know there are different options there, but we just pick those online version as a standard for marking. So, and I hope you already tried it out. When I'm walking around, I see a lot of students already got it down, either in a terminal or on online compilers, and that's pretty good. But still, there are some of students still wondering how to get it down. Don't worry about that. Today, it's just for have you feel about what is Python and what is programming. The most important thing is to understand the procedure, to understand what is important and understand what it is doing, rather than doing it by yourself. And it's reserved to the weeks after. So don't worry about that. Don't worry, forget about the compilers, forget about this Python code there if you can't get it down, and we will help you to get it down later and immediately next week. So beside the Python and programming, and here are something about the course I have to introduce. And here is it. And so here is a tentative roadmap about those Python, about this course, all right? So lecture 1, what we are doing here today is just for a general introduction. And the lecture 2, we're gonna teach some basic stuff like setting up the environment, like using a compiler, and like the basic input and outputs there, like what we have introduced. So this is get it done part. And next week you should be able to at least program the hello world and get it run successfully on your computer or on the online compilers. So that's second lecture 2. And lecture 3, we're going to play with numbers and loops. We will do the calculation, and we will teach you how to do actually a pound calculation. We will use the loops to build much more complicated computing using your computer. Then at the same time, we're going to release the assignment 1. We will assign, there is one assignment for you. And we will introduce how many assignments we have there in total and what's their weights and your final marking later. In lecture 4, we teach the characters and the strings. We will explain the concepts later. In lecture 5, we will play with the control flow because the computer is actually not that smart, but with the control flow, we could have the computer to recognize different situations. That's what control flow is doing. In case 1, we're doing this. In case 2, we're doing that. This is control flow. We're teaching that in lecture 5. And also lecture 6, we play with functions. Function is a basic component of programs which we're gonna introduce next week. So don't worry about that concepts. And here we're gonna have the second assignment. And also in lecture 5, I forget to mention that this is the first time in class tests. We don't have the midterm tests. We decompose them into 4 in-class tests. So I think that will be better for you based on my experience and the experience of my colleagues. That will be better for you. So in lecture 5, along with lecture 5, we're going to have the in-class test there. And after lecture 6, we're going to release the second assignment to you. In lecture 7, we're going to play with lists. This is a concept I'm going to introduce later, and I'm going to skip it to avoid to confuse, bring confusion to you. And lecture 8, data collection, and also the second in-class test there as well. And lecture 9, we will teach you how to play with files. Files is just like the text files, document files, different types of files there. But we're going to teach you how to deal with a text file, like how to save your result files, how to read the inputs from files, because you're having the background of engineering. It happens a lot. We have to deal with numbers, deal with a lot of data we collected from the projects. And usually those data are saved or stored in the files. So we have to learn how to deal with those files. Based on these files, we can do the calculation and get the user what they want. So this is lecture 9. And also we're going to release the third assignment there. And lecture 10, here is some introduction about the class and objects. This is a concept we are going to introduce later. Application, lecture 11 is we're going to demonstrate you, show you how to build the actual application to make the program into an application. You have seen a lot of applications like the Office software, like the smart building, because you guys are from civil engineering. The smart buildings need a lot of programs to deal with those sensors, control the lights, speakers, or something like that. Those can be implemented with Python as well. Maybe I can give you a demonstration next week to show how to control that with Python. But in lecture 11, we're going to teach you how to do it. And also at the same time, we're going to have the third in-class test there, and also release after the lecture. We're going to release the course projects. And lecture 12, we're going to teach some advanced topics, more about calculation. So let's reserve that part. Lecture 13, we're going to have the last in-class test. This is, we're trying to imitate the final examination with the first in-class test there. So to help you better prepared with the final examination. So if everything goes well, we're going to have the final examination, and hopefully it's face-to-face. I prefer face-to-face more over this online because we could have better communications there. And I believe you will learn more from there by face-to-face. Okay. Today I appreciated a lot of students ask a lot of questions and also provide feedbacks. to help us to optimize this course. And course websites, and basically we're mainly using the Blackboard. So go, I guess you already use the Blackboard a lot, right? Sorry, just talk too much. Let me take a break for seconds. Sorry, I'm gonna drink some water. As mentioned, we're going to release the materials, the teaching materials on Blackboard. Like what I have mentioned, we're going to share the slides, lecture notes of this lecture on Blackboard. You will find it there. And then how about we just open up the Blackboard? So, on a Blackboard, you're going to find this course. It's Comp 10, 12. It's here. So this is the place we're going to share the slides here. Lecture notes and tutorial notes, and also the some of the source code of the programs. We're going to share it here, and also we're going to put the videos here. We will slightly modify the lecture video for make it better for you to review the content, and we will share that video here. So be sure that in case you need the course materials, lecture notes, get here to find it. So, and also I forgot to mention this quite important here. We actually prepare a survey. You can find there is a survey here. Help us know you better. I actually mentioned in the announcement. Some of students already take that survey, but I think it will be better if there are more students can take that survey to help us to understand your programming experience and also what's your expectation about this course. We will put a new survey there for you. I hope you can complete the survey and help us to understand better so we can customize the content of this course for you. Because even Python itself, we think is simple, but I think that there are a lot of concepts there. A lot of them, I don't think it's necessary because, for beginners, especially. So anyway, we're going to announce, we'll put the announcement on the Blackboard, slides, assignments, projects, or such kind of stuff on Blackboard. Okay. So be sure to get the things you want and the materials from there. And lecture, it's face-to-face. At least at this moment, it's face-to-face. I hope the situation of the pandemic is getting better. We can continue to have the face-to-face lectures. So it's at this room, they're already here. And the time, we have 13 weeks there for the lectures, as I already mentioned previously. For labs, there are 3 labs there. And we'll deliver some of tutorials in lab sessions. And it's at here.
the M409, and there are 3 time slots for the labs. We have 3 of them. You should have been already assigned to one of the lab session, right? So I think your host department already assigned you to one of those labs there. And so I encourage you just go the lab session which you have been assigned. But I understand sometimes you probably have some conflicts on lab session time. It's okay for us if you jump from one lab session to the other, but we don't encourage you to do that because we have limited number of computers in that room. If there are too many students are jumping between and lab sessions, it's probably could happen that you don't some of students don't have the machines there to try it out. But as I mentioned, do it if it's a last option for you in case there is time conflicts about the lab sessions you have been assigned. And also, the lab session will be broadcasted online as well through the team group. So you can, if you're jumping over lab sessions, other option is you can actually participate online. And we answer questions there as well in team groups. Okay. Those are timetable. And this page, I think, is you concern the best, right? So it's marking assessments. We have continuous assessments, including 3 assignments, as I have introduced previously, and 4 in-class tests, and 1 project. Those are continuous assessments, and the final examination. So the weights we put is something like this. For continuous assessments, there are 65% of them. By breaking them down into 3 assignments, taking 15%, and that in case, that is to say 5% each. And we accept late submissions, but only up to 3 days. But we put 10% deduction per day you're late. For in-class tests, which take for 40% in total, that's 10% each. It's open book, open internet tests. You can use whatever materials you have there in the in-class tests, and I think you have to worry about that part. And 1 project which takes 10% of the total marking, and it could be group project, but we accept the group, a team up to 3 persons, but you have to, as long as you have multiple person in one team, you have to show us the roles assignment to your team members and explain what exactly he or she is doing in the team, and make sure everybody is a team player in that team. So we will come back to that later. Anyway, we allow group projects. Also, you can do it as an individual project as well. But let's get more details later. Today, just for your information. The final examination is open book and maybe open internet as well. And I'm not sure it should be a paper-based or online-based. For in-class test work, do it in the Blackboard. So it's online test. But final examination, because this semester we're doing face-to-face. In the last semester, we're doing it online. So the final examination is online tests. But if we're doing face-to-face, probably is a paper-based examination rather than an online one. But let's make a decision later. It depends on a lot of things. Depends on how much you can take it. Depends on the time, and also depends on the situation, the progress of the pandemics. So let's make a decision later. We have zero, this is quite important for all those stuff, assignments, in-class tests, project, and final examination. We have a zero tolerance to cheating and plagiarism. This is quite important. So even I know that's probably a lot of, this has been introduced a lot, but it's quite important. Yeah, we need you to take it serious. One last thing is the references. I already got several students ask a question. Is there a textbook where I can read or I can follow? I would rather say it's a textbook, that here are some references you can use. It's all about pattern. But the way I'm suggesting of using that book is rather, it's not to read through all the pages. I would rather to have you use that just for references, because those textbooks are written in the way that it need to be comprehensive and systematic. It's gonna cover a lot of things. Among them, I don't think there are some of the content I don't think it's necessary for you, and probably it's not easy for beginners as well. So what we're doing here in this course is trying to deliver the most essential, most fundamental stuff for beginners to get everybody on board. So we're trying to minimize the content you have to learn. I think that will be easier for you. And as you have seen, we're trying the best to make it fun. So I believe it's easier to learn. And those books can be used in case that you really need to know, you really want to get an in-depth understanding about some of the concepts. Go that book. Read it through, you will have better understanding rather than what we teach here, mostly for beginners. So, and also, there are some of the contents may not be covered in this course. I believe they're in that books, and but even probably we're not use this content for examination. We're not testing it either in the test or in the examination, but it's better to understand it. You can read those books. So this is the difference between our lecture and those books. In summary, those books are very comprehensive and systematic. It's rather really thick. So we can minimize that book in a couple of pages here in this course. So I think this course will be easier if you're a beginner. And also, there are some online tutorials, and also this is another question asked by the students. Some of tutorials online, they usually by design, for completing a specific task, for example, read a file or do a calculation or something like that. It's really specific. Sometimes we may have similar tasks. That's the right time to use that tutorials. Maybe we'll introduce some of such tutorials to you as well. You can use the tutorials like that way. Compare back to the lecture here and those textbooks here. Those tutorials are more specific. So you should use the tutorials in that way. Okay, what I'm saying is actually it's too specific rather than systematic. So our lecture is something in between. to fit your specific need, and at the same time, we are systematic. We introduce the whatever necessary concepts for you to get you on board. So, okay, and that's pretty much the stuff I'm gonna introduce today. We take short breaks, so we save a lot of time. See if you have. See if you have further questions there. Take. If you're shy to ask a question, we can talk offline, as mentioned. So let's do it like this is pretty much the content I'm going to introduce it today. So it's okay if you don't have further question, you can leave. We save a lot of time there. But in between, I will stay here as well. I will go walking around. Oh, you have a question, Nathan? Yeah, that's right. The lab session starts from week 2. This week, you don't have the lab sessions there. That's why I mentioned that this week you don't have to worry about anything. We are not actually doing it. The hands-on experience will be built from next week. Okay, good question. Thank you. So anyway, we will stay here until the end of the official time. In between, should you have any question, just find us here. If you're okay with it, it's okay to leave. Okay. Okay, thank you very much. See you next week. Thank you.